All right, so when you look at the different uh, options for our sum of two three-digit numbers that then give us uh, a three-digit number with the remaining digits, some of the things you might have recognized in that process was, first off, each of them involved a regrouping. Now, what is a regrouping? A regrouping is, you might have called it carrying when you were learning addition. Now in elementary school, they call it, instead of carrying, they call it regrouping. So not sure what it was referred to when you guys were in elementary school. But here's a proof of why there's regrouping. Now in higher level math courses, often proofs are done by what's called contradiction. So you assume something to be true, then you run into a problem, and then that shows what you assumed was not there or was not correct, so the opposite must be true. So first off, let's let A, B, C, D all the way through I represent the digits 1 through 9. So we've got those added up. Well, if you add the digits 1 through 9, we know that it should equal 45. So that's one thing that we know first. And arbitrarily, we're calling G, H, and I the sum. Um, okay, so we're going to assume the opposite of what we want. We're going to assume that there is no regrouping. Then if there's no regrouping, then C plus F must just give us I, B plus E must give us H, A plus D must give us G. And that's what that's showing us here. Well, in this line 1 here, we can do a substitution then. We can replace A plus D with a G. We can replace B plus E with an H. And C plus F we can replace with an I. So doing that, we get this. Well, notice now you have two of each of those. So 2G plus 2H plus 2I is 45. Pull out a 2 and divide. Well, that's telling us that G plus H plus I has to equal 22.5. Well, each of those digits, so they were integers. So you can't possibly add them up and get a non-integer value. So that's not possible because they should have been whole numbers. Therefore, what we concluded, or sorry, what we assumed must be false, that there's no regrouping, meaning there must be a regrouping. Right? So we just showed that there has to be at least one regrouping. Now that one might not have been an obvious thing that you noticed, but something that might have been more obvious is the sum of the digits in our solutions was always 18. Okay, if you looked at all the ones that people posted, and if you didn't see that, you can look back and just to confirm that. But we're going to prove that here. So our solution, remember, is the GHI. We'll start out the same way, that the digits should add up to 45. We're going to do contradiction again. So we're going to assume the opposite. Um, oh, sorry. I guess since we know there's a regrouping, we've got to say, okay, where's that regrouping going to be? We um, we know the regrouping can't be in the hundreds place because then that would give us a 4-digit number. So it's got to be either the ones digit or the tens digit. We're going to do it for the ones digit, and you could do the same exercise for the tens digit and it would produce the same result. But we'll assume that it's in the ones digit. So that means C plus F is going to give us 10 plus I, because I is the ones digit, that means, and then you have the one that the 10 or the one that's being carried over. So C plus F must be 10 plus I. B plus E plus the one that you carried over should give you the H, and then A plus D should give us G. Well, if we do our substitution again, so C plus A, F will be replaced with 10 plus I. We're going to subtract the 1 over, and B plus E will be replaced with H minus 1. And then the A plus D is G, and then you got the GHI from before. Well, if you move your constants over to the other side, so add the 1 over, subtract the 10, we end up with 2H, 2G, and 2I is going to give us 36. And then notice when we divide it over, G plus H plus I will give us 18. So that proves that the sum of the digits in your solution is going to give you 18. Um, and you could do the same idea for the tens place, but um, not in the hundreds place. Um, so now suppose you had regrouping in both the tens and the ones digit. So that would mean C plus F again is 10 plus I. When we do our B plus E plus 1, it's now being 10 plus H instead of just H because we're having regrouping. And then A plus D plus 1 would give us G. Doing the same substitution and doing pretty much the same process we did in the other two, we end up getting a decimal answer again. So that shows us that it wouldn't work. And also, we just proved that the sum should be 18. So that's also a clue that it doesn't work as well. So actually, from these proofs, we proved that the sum of the digits in the solution has to be 18, and that there's exactly one regrouping or carrying that must take place for our solutions to work out.